Bismillahirrahmanirrahim. Assalamualaikum warahmatullah. This video I believe will be part 15 of my SolidWorks mini vacuum cleaner project. Alright, in this video I will do another detail drawing of the other parts, which is the impeller. So I will try to put the impeller and the on off button and rear cap. If possible, I will put it under one drawing. Okay, sometimes you can do one drawing sheets of your detail drawing. You can share multiple components. Right, so here there is the front casing, so I will make a copy of it and then I will paste it, and simply I will go after selected sheets and I click OK. Simply click yes. Then now I have here at the bottom is the duplicated version. So this one I will go for, I will rename it. Alright, okay, I will rename it as Impeller. I cannot name it too long because we have kind of limited number of characters here. On off button and rear cap, right? Rear cap. I try it, rear cap. So this will be the three parts would be in this new drawing. Okay, hold on. So this drawing, then I will delete this view and this one as well. Alright, here the title block I edit it, and this one will be this one. Well, the name is Impeller, on off button and rear cap. Okay, material I will not put it, since later I will show you how I will delete this. So drawing number, this is supposed to be drawing number 3, and the scale later I will decide whether the scale 1:1 is good. Then now I'm back in drawing mode. Alright, okay, now I will open the impeller part file. If you look in this view palette, this is not the impeller, this is a front casing. To open the impeller here, I can click at will browse the impeller part file. So this is my folder where I've done all the part modeling. So I will go for impeller, I click open. Alright, now it's already listed impeller. As you can see in the menu here, we have all the views that we can drag into this drawing of the impeller part modeling. Alright, the way I've done the part modeling for the impeller, as you can see, actually the right view, on the right plane, so the right view is actually kind of like a front plane in the drawing. I just click at this right view here, and I click here at this location. Alright, as you can see, if I drag it here, I can go for the left view. I put it here, I can go for the plan view, and here I can go for the isometric view. So I just only need the isometric view, and I don't want the left and plan view. I just click OK. Alright, about the isometric view, I can make sure that tangent edge remove, and I can go for shaded mode. So I just put somewhere at this location. Alright, here for the impeller, also for the front view here, so tangent edge remove. Since this is not a section view, I need to show the hidden line. Actually, we don't have any hidden line because the way the geometrical shape of this impeller, we don't have any hidden line. Whether at the back there is no hidden line. Alright, for the impeller, I need to make on the left here is section view, so better to make it section view rather than typical orthographic. So hold on. Okay, under the drawing here I have a section view, then I can go for vertical. So I will select at this point, I click OK. I can bring my left section view here, and Alright, about the direction of this section, cutting of this cutting line, yeah, I can go to flip, so we are more on third angle projection. And okay, let me click OK first. Alright, about the labeling here, I will go by the first letter. I can go for H, make sure capital letter. And now we have section H here. So this one about the text here, we have to be let me type first, section H, and if I double click at it, I need to make it 4 millimeter, right? Not too big. 4 millimeter is about the standard size for the footnote for this title for this section H. Alright, another thing about the hatching line, yeah, I can make it, okay, density is 345. Okay, let me save my file. Okay, now about the another thing, any circular shape you have to put a center mark. So this center mark by default is not good. I just delete it. Here under the annotation I have center mark, select the circle. Okay, by default is using use document default. I uncheck it. I want to use not 2.5, I use 1. Then I click OK. It's kind of like we have the line type scale is more appropriate. Okay, now I can do the dimensioning. Okay, the reason for me to do section view, because I can easily to avoid in terms of to facilitate drawing easy, we want to avoid any hidden line, so better to make it section view. Okay, now for the dimension, diameter, better you go for where you can see the true shape of the circle, better to be at the front view here. So I will go for this one. Radius 22.5. okay, sometimes you don't want to go for radius, better to represent it as a diameter. Under the leader here you can go dips option and it goes for diameter. If you bring your text like that, so the arrow head is pointing like this, so I just simply bring it like this. And another thing is about under the value here, no decimal point, so this will be the diameter. Okay, and another thing important diameter is we have a pin here. So this is a pin. We have the center hub there. Diameter is 4, and also we have the inner holes there. Actually, this will be mounted onto the shaft of the DC motor. So I will select this circle, and I can put at this location. So this diameter 1.5. Alright, another important thing is that I can show, since as I mentioned before, for plastic component like this, we don't have to do really detailed dimension. For example, what will be the curve of this cutout when you're looking at this section view. The way I do, we have a cutout here to make the blade. That is not necessary for this case, because the only dimension that we put for this plastic component is only that we can show in terms of assembly and fitting and certain important dimension. Alright, so I will go for the important dimension only. I go for what will be the total thickness of this blade. I can go from here to most at the end here, and it goes for 11. I can put it here, so this will be the total thickness 11. And another thing is about this one, what will be this length from this point to this point is not significant. Will be the tube. As you can see at the center we have the hub there, and I can give dimension from here to here. I can give 9. I put it here, so this 9. And another thing is about what will be the diameter of the hole is already given. Okay, another thing before I forgot, center line, we must have center line for this one. Okay, we must have the center line. And okay, how about the thickness? So I have to give the thickness from this line to this line. The thickness is 1. Okay, if I go for this upper side and for this icon, so everything will be shifted, so I need to drag it down. You have to obey the standard of dimensioning. You mean you're not too far away. The shortest distance cannot cross, the extension line cannot cross the dimension line, so you have to put the most the shortest distance will be at the first level, not too near, not too far, about 2 letter heights for the first level, and about the second level, not too far away or not too near, at least about 1 letter height, like this. Alright, okay, let me drag this thing about this position. Okay, save again. Okay, I have the dimension for this one, and I already given this one, the length of the tube there, and thickness already given. I believe, yeah, I already give the main diameter. Okay, one thing before I forgot, yeah, this is important. Sometimes when people read the drawing, they need to know what is the number of this blade. I don't have to give what the radius of this one is, not significant, because the way I've mentioned before, the way they fabricate, they manufacture this impeller, this is not a metal parts. They are not doing this by milling, drilling, or lasing, or something else. This plastic component, they send it to CAM will translate to CNC machine. CNC machine will do the metal mold, and the metal mold will be put into the injection molding, and in that injection molding, then how they will produce this impeller. So if this is the way they manufacture this part, we don't have to give detailed dimension, unless your part is a metal part where we need machinists like drilling, lasing, and so on. Alright, so only the necessary dimensions only for the main thing is about assembly and fitting. Alright, okay, so now I will put another important note here. Since the number of blade is 9, so I will go, we have notes, so I will put somewhere at this location and put the measure capital letter. You put number of blades 9. Right, so I think that's all. This enough already information for this kind that we call the detail drawing of this impeller. Okay, one more thing before I forgot. This is important. You have to make we have a local node here, right? So because we have to put the multiple parts here, later I will put the on off button and also the rack cap. We have to put the local node as well. Here I will put the local node. So the first is the part name, so this is impeller. Then I go to the next line. The second will be the second one will be the material. The impeller, as mentioned, the material of the impeller is polypropylene. Okay, the material is polypropylene. And the next line will be the we have name, material. The next line will be the quantity. Okay, the quantity is 1, and the next line will be the scale, but I don't think so. I will put the scale since I drag this view of this impeller in 1:1 scale. As you can see here, it's 1:1 scale, so I don't need to put the scale. Unless for the it means for the on off button, I will put into the same drawing here. On off button is really a tiny component compared with this A3 size. If I do on off button 1:1 scale, it will be so small compared with this A3. It means that for that on off button, the footnote about the scale, I will go maybe 2:1, 3:1, or 4:1, so it becomes bigger. So that's what so it means that for this on off button, I will add scale at the footnote. For this one, no need. It means it refer to the main scale of this title block 1:1. Right. Okay, another thing important, you have to put the part number. Alright, to put the part number under annotation, we have balloons. So I click like this. We have the circle. Alright, if I click this at this balloon here, the setting on the left here, we have balloon text. I will not go for item number, I will go for text. Simply I tap the number. So what is the part number of this impeller? We refer to your BOM is part number 3. So it means, hold on, so this one, text I put 3, so we have a part number. Alright, okay, I think this is good enough for the impeller. We have the part number, the name, the material, and also the quantity. Alright, okay, I save my file. Okay, now it's about the, okay, later I can drag all this view to repositioning the, make sure that the part, to make sure that the all the three parts that I want to do in this drawing in uniformly distributed in this drawing. Alright, the second one will be the on off button, and I will browse for on off button. So I will select the on off button, then I click open. Okay, now if you see under the view palette, we have in the menu we have all the views for the on off button, but one thing I need to mention, here if I drag the front view of my on off button, I put it here. As you can see, the orientation of how I've done the part modeling is on off button is not at the vertical orientation, so it kind of like it have with an angle, because since from the beginning when I do part modeling of this on off button, I make the part modeling of that on off button in assembly mode, and the orientation of that axis of this on off button is perpendicular to the axis of the handle of my main body, main casing. So it means if I put it the way the orientation is hard for me to do, kind of not a standard view for this detailed drawing. So in order to solve this problem, let me show you. I don't want the on off button at this orientation, I need it to be in vertical orientation. So let me cancel this thing. I need to delete this first. Okay, what I need to do, hold on, I need to open the, let me show you, I need to open the assembly file, full assembly that I have done. So this will be the full assembly. Alright, in this full assembly I will click at this on off button, so I will open part in position. Okay, like I have mentioned to you, if I go for front view like this, the on off button, the orientation is at this angle. Okay, this is the original on off button part modeling file. What I need to do, I need to rotate it to the vertical orientation, but I don't want to disturb the original file, since whatever changes I make, like I want to rotate it to make it vertical orientation, it will affect the assembly that I've done, also the assembly drawing and so on. Alright, so I don't want to disturb the original file, so it means I will make a clone version of this file. So what I will do, I will go file, save as, copy and continue, not save as copy and continue. I will go for, I will make a clone version of this will be the on off button 2. Alright, so it means that I have made a separate file named on off button 2. So whatever changes that I've done for on off button 2 will not affect the assembly and so on. I close this one. Okay, I open the on off button 2. Now I have on off button 2, so this is the clone version. Alright, if you look at this on off button 2 file, if I show you again the front view, so I want to make this on off button vertical, straight vertical. I need to move, rotate it, right? I need to rotate this on off button, but I need to know what is the actually the angle. As you can see, there is a plane I've done to do this. If you look on the plane one, so this is a plane one at this orientation, so I need to know what is the angle between this plane one and the right plane. So this is a standard right plane. I need to know the angle. So here under evaluate here, I have measure. So the first one I will select the plane one. So the plane one is that rotated position, and the second will be the right plane. So it stated that the angle is 10 degree. It's 10 degree. It means that, okay, let me close this thing. So it means that the rotation of this on off button is at 10 degree. Okay, 10 degree. If you look, the axis at the bottom right corner is 10 degree of the Z axis. So I need to rotate this on off button here 10 degree on counterclockwise. Okay, to do this, insert features, I will go move copy. So I will go for this setting, for this to move copy. I make sure that I uncheck the copy, and I will select this on off button, not under translate. Actually it's like this, default is under translate, but you have go to under rotate here. So I want to rotate at Z axis negative 10 degrees. So here under the Z axis I put it negative 10 degree, then I click OK. Now I click OK. Now if, as you can see, if I go to this front view. Now my on off button 2 is in vertical position. I click OK. So actually I need to show you it will not affect the full assembly file if I show you, since this is not on off 2, so this is the original one on off button. Alright, so that's the way to do it. Okay, let me close this thing. And alright, I have this on off button too. If I go back to the drawing, okay, if I go back to the drawing, okay, now I need to insert under view palette. I will insert not on off button. I will go for on off button 2. On off button 2. Now this is a menu of my on off button 2. Now I have the right orientation, so I will go for the, okay, at this view palette I will go for the left view. I select the left view and I will drag it to this drawing, and I need this isometric view. Okay, let me escape, and now I will drag this somewhere at this position, and this one at this position. Later I will adjust the position of all the parts after I put the other parts, which is the rear cap. Alright, but first this is on off button. Okay, the on off button I already mentioned this is 2-1 because 1 is too small. Okay, another thing is about I just need to mention we have a on off button when, if you look at the way how I do the part modeling of this on off button, if I want to do dimension of diameter of this shoulder in this drawing, if you look at this drawing, if I want to do the dimension, hold on, okay, if I want to do a notation dimension, I want to give the major diameter, it cannot point circular edge here, but this one I can do. If I want to do dimension, I can do the inner circular edge, but at the outer circular edge it cannot point to put the dimension for the diameter. Right, this is because the way I do the part modeling, hold on, this is the way I do the part modeling of the on off button. Actually the way I do the part modeling is of this on off button by not direct boss extrude from a flat plane, from a sketch plane, but it start from a plane, but it end up at the curvature surface of the main casing, the front casing and rear casing. So I have kind of like the outline here. It's a projected curve, but when you're looking at this, it's actually a full circle, but actually it is a projected of the circle. If I want to do dimension, if you do back at the drawing, you cannot detect that circular edge. Alright, in order to do this, okay, I open back the part modeling of on off to button 2. I need to create a kind like a sketch here, since I have a hold on, since this is a flat plane, I would create a sketch. So I would draw a circle, make sure it snap at the center point, and like this, and I need to select the relation. I select this curve and this endpoint, I make it to coincident. So now I have a full define, so I can use this curve for me to do dimensioning in the drawing. Okay, I save my file first. If I go back to the drawing, if I go to annotation smart dimension, it still cannot point. Okay, this is because SolidWorks is not updating the view. It means that I need to show you again. I need to insert again the view under the view palette. So SolidWorks will updated. It will be updated because I've add a circle there. So I go back to the left view again. I drag it there. And now if I want to do, okay, I cancel this thing. If I want to do annotation smart dimension, then only it can point out. Okay, actually it's not showing again. This is because I have not on the view. I have to on the sketch. Okay, I have to on the sketch because the circle that I have just created is a sketch. So now if I do smart dimension, now it can point the diameter. Alright, it can point the diameter. So this one I go for done. Okay, only the important dimension need to be shown for this on off button. Okay, okay, another thing about the center mark, I don't want to use this one, and make sure that right. Another important dimension is about, okay, now I can, as you can see here, we have a, because I on the sketch, so it means view, I need to hide it so I don't have that point showing here. Okay, another thing is about this, supposed to be shaded like this, right? Okay, now this is actually this, I can call this front view for this on off button. Okay, the idea of it is I need to make a full sectioning for this on off button, right? So to do full sectioning is, then I will do drawing section, then I will go for vertical and I click OK, then I go to this side and make sure that flip direction, so this full sectioning. Okay, this one is already section HH, this is supposed to be section UU, so I select this one. This one is H, what I mean, this one is supposed to be section II, so make sure capital letter I, and this one have to be section II one, and the text must be 4. This section I. Then another thing is about, be careful about this, your hash I will use and so we must have also the center line. Right, as I mentioned, only the important dimension only, and then I will go for, since we have a pin here, I will go, this pin will be touch the tactile switch, the PCB tactile switch. Right, another important dimension, we don't need to show everything, like what is the thickness of the shell, that is not significant, because I already mentioned this dimension for plastic components only meant for assembly and fitting. Right, another important is, okay, I already showed this major diameter is 70, because this is important. It's kind, we know what is the shoulder diameter. The important diameter is this one, the diameter of this outline. So it made this one, because this will be fitted into the whole of the front area casing, so this one need to be shown. This diameter I need to show it, diameter 13.8, right? And this one is important for fitting. Okay, another important dimension is about what will be the I can go for what will be the thickness from dimension, from thickness, maybe I can go for this point to this line, and what would be the alright, I think this is good enough already to show the dimension. Okay, to show the dimension of the maybe I can give another dimension, is about the thickness from here to here. Right, so let me drag up until this position, and this one I need to shift it at this position. This one have to be no decimal point. Right, let me save my file again. Okay, one more thing is about here, this the footnote of this on off button. So I will select the, okay, what I will do, I will select this thing, and copy and paste it. Alright, the name, okay, the part number is, if you look at the exploded view for the on off button, part number 6, right, it would be part number 6. So I click at this balloon, and under text I put it 6, and the name is on off button. Okay, this is on off button, and the material for on off button is ABS, right? It's ABS. Alright, we have the part number, we have the name, part name, and we have the material, and we have the quantity. Okay, since I zoom this on off button is 2-1, alright, 2-1, so I need to put at the bottom node here, I need to add scale to 1, so it shows that this on off button is not full scale. This is 2 times bigger to 1. About the impeller is, I don't show the scale because it will refer to the main title block. The scale is 1:1. Alright, the next is about another component is the rear cap. Alright, so I go to view palette again, then I will browse for the rear cap. Okay, for the rear cap I will go for the right view, so I will drag it here, and another one is about the ISO view. Okay, I press escape. Alright, about this view, at the setting on the left here, so I will go for full scale. This one, tangent is removed, and this one as well. Alright, about the center marks, I go for 1. Okay, since I need to make a full session view, this is not session view, so I need to show the hidden line. Alright, about this one, no hidden line. Okay, let me drag it's about positioning. Okay, for this recap, I need to do a full section. So I will put this direction, then I go for flip. Okay, this one, the section line, the hatching, hold on. Okay, about the section view. All right, the section view is since I already have HH, I, and this one will be J. Okay, about dimensioning the rear cap, as I mentioned before, we don't have to put really detailed dimension, only for assembly and fitting. Alright, since the rear cap, this one, at this point at the back, this one's supposed to be mounted onto the slot, cutting slot of the rear casing and also front casing. So I need to give a dimension of that diameter. So it means this one, this outline. So I need to put this diameter 49. And also important dimension is about the I can give the total thickness. And it's about center line. Okay, another important dimension that I should put is about maybe I can go for, I have this one, the thickness, and also the main diameter here, but actually this is enough, but I should add more, maybe about the, since we have a repeated pattern here, circular pattern, maybe I can give dimension about kind like what will be the angular dimension, 23, and what will be the, actually this is kind like the way I do it, this is not parallel, so maybe I can go for kind of like what would be the diameter here, this diameter, and also the hidden line diameter here. So we have a hidden line, but the hidden line is actually the, I cannot put it here because kind like not showing the profile of the circle. Maybe I can go what will be, because this is the profile of the cutout, I should put the diameter here, 32. Okay, I think this is good enough to show some description about the size of this rear cap. Okay, actually this is not the detailed dimension. I think it's good enough for this rear cap. And the most important thing is about how do we fit to the, we mounted this rear cap onto the rear casing and also front casing. We need the diameter at this point. From this point, already given diameter is 49. Alright, about the, so I will copy and paste this one. So the alright, the part number, okay, about the part number, the rear cap will be part number 7. And the material is for the rear cap, the material is ABS as well. Quantity is 1, and the scale that I've done for this rear cap is not scale to 1, so I need to delete this. Okay, since the rear cap will refer the scale of this rear cap compared with this A3 size is actually the 2-1 is meant for this one, the on off button. If you want to check what will be your scale of your viewport here, you can check here at the document properties. So for the rear cap is 1-1, so is okay, it means that this rear cap will be referred to this drawing, the scale 1-1. Alright, same goes for the impeller. Okay, I think I have completed this detailed drawing of this impeller, the on-off button, and also the rear cap. I have put the drawing number 3. I already put in the exploded, the BOM of the exploded view drawing number 3. and also the same goes for the BOM of the those three components, the impeller, the on off button, and the rack cap, drawing number 3. And alright, inshallah in the next video I will see you in the next video for the other 3 parts. I need to mention that the other 3 parts will be the dust container, the dust container valve, and also the crevice nozzle. Alright, I need to mention that I found out that HEPA filter, the HEPA filter is not is a standard part, so it means this company who design and manufacture this mini vacuum cleaner, they will not manufacture this HEPA filter, they simply order it from the vendors. Alright, so if this is the case, so the HEPA filter will be a standard part, and we will not show the drawing of this HEPA filter because the drawing is already done by the vendors. Alright, so inshallah I will see you in the next video for the other 3 parts. But before that, please do not forget to click like, subscribe, and promote my video to your friends. Assalamualaikum warahmatullahi.